The Hubble Telescope by Sue and Rebecca. This is the Hubble Telescope. It is a massive telescope floating in space. Launched in 1990, its purpose was to take clear photos of deep space. Its size is about as big as a school bus, and its weight is equivalent to 2 adult elephants. The telescope's name came from astronomer Edwin P. Hubble, who discovered many important aspects about the universe.
The Hubble Telescope is not just any telescope. This innovative piece of technology has solved one major problem in astronomy since the creation of this world: an unobstructed view of the universe. This problem was caused because of one factor: the atmosphere. The uneven heating by the sun causes shifting in the air pockets in the Earth's atmosphere, which distorts the view from the telescopes on the ground, resulting in very blurry images. The Hubble Telescope solves this problem as it is above Earth's surface and atmosphere.
Hubble has provided clear images of planets, stars, and galaxies, greatly advancing astronomers in their understanding of the universe. In 1990, Hubble has made over 1.3 million observations.
Prior to the invention of the Hubble, scientists could only predict that the universe was 10 to 20 billion years old. With the Hubble being able to observe Cepheid stars, astronomers were able to measure their brightness, which enabled them to calculate the distance from the Earth. Using this information along with others, scientists could accurately predict that the universe is 13.7 billion years old.
Hubble has contributed to the discovery of vital aspects of our universe. It discovered that almost every major galaxy is anchored by a black hole, which sucks everything around them, even light. It discovered the 2 moons of Pluto, Nix and Hydra. It helped scientists understand the rate at which our universe is expanding. Hubble has also unleashed details about powerful explosions of energy from stars collapsing, called gamma-ray bursts. Hubble's extremely clear vision also enabled scientists to identify the distribution of dark matter in space. Here's how Hubble works. Just like all telescopes, Hubble collects more light than the human eye can capture on its own. Its telescope mirror measures 2.4 meters, which is rather small compared to current ground-based telescopes, but its location above the atmosphere gives it clear quality. As Hubble travels, it catches light and directs it into its multiple science instruments.
The Wide Field Camera 3, one of Hubble's newest instruments, has a much better resolution and field view than the other instruments. It is used to investigate dark matter, dark energy, the formation of individual stars, and the discovery of incredibly distant galaxies.
Next, the Cosmic Origin Spectrograph, another new instrument, is a spectrograph entirely in ultraviolet light. When examining an object, this will identify its temperature, chemical composition, density, and motion.
The Advanced Camera for Surveys helps identify the distribution of dark matter, discerns remote objects, looks for big planets, and investigates the evolution of clusters of galaxies.
Next, the Space Telescope Imaging Spectrograph is known to be able to search for black holes. The Near-Infrared Camera and Multi-Object Spectrometer is Hubble Telescope's heat sensor. Its reaction to infrared light enables it to see objects hidden by interstellar dust and look into deepest space. Finally, the fine guidance sensors keep Hubble pointed in the right direction. They can accurately measure the distance between stars.
Each one of the Hubble's instruments/functions is powered by sunlight. When it is in the Earth's shadow and is not exposed to sunlight, it uses its electricity from the solar arrays that convert sunlight into electricity.
Although the Hubble telescope has allowed scientists to discover so much about the universe, it does have its limitations. The Hubble telescope cannot observe the sun, as the intense light and heat would fry some of the sensitive instruments in the device, and because of this, the Hubble telescope is always pointed away from the sun. This also means that Hubble cannot observe planets like Mercury and Venus. The Hubble orbits the Earth, and sometimes the Earth itself can block the object that astronomers want to learn about, meaning that the Hubble only has a limited time to observe an object. Shortly after the launch of Hubble, astronomers realized the images and observations were blurry due to a mirror flaw that could have been avoided, and this raised some questions as to if NASA's employees were capable of carrying out all their duties, creating an ethical issue. The cost to fix this flaw was a steep price of $1 billion, which was an economic challenge. Thankfully, NASA invested more money into this project, and the Hubble was considered one of the most successful missions of NASA, and is still operating today. In conclusion, we believe that the Hubble telescope is immensely important and has assisted astronomers learn an unbelievable amount of information about our universe. Although the Hubble was highly expensive, costing NASA $9.6 billion, scientists agreed that it was worth every penny. Think about it, without it, we wouldn't even know how old our universe is.
Created using Powtoon.